This is actually not lesson 4, it's lesson 3. It's lesson 3. And what we're doing today is we're graphing linear equations. So we're graphing linear equations and a linear inequality. A linear inequality. It's a linear equation. So we have our dependent variable y. We have our slope. We have x, the independent variable, and we have a y-intercept. This is our y-intercept p. All right. The only difference is we have this inequality. We're dealing with an inequality. We have more than one variable. Okay. So far we've only like looked at inequalities in one dimension. So like we looked at it from side to side, like on a number line, for instance. So I'm gonna draw a number line real quick. So I'll have a number line here, right? Here's all my little tick marks. And if I draw an inequality, all you're going to see is some hole somewhere and then some direction to tell me something about that inequality. So this would be less than. All these numbers, I said like x is less than, we'll say 2, right? But where we are at is we're doing two-dimensional graphing. When you're talking about linear inequalities, you're doing two-dimensional graphing. So, here we're only dealing with this x-axis, but with the linear inequalities, we're dealing with the y-axis and the x-axis. And let's say we have I don't know, some line, and I'm going to draw some line. Then if I wanted to shade, like less than over here is to the left. But if I want to shade less than on a two-dimensional graph, I'm going to be shading below the line, right? And if I want to shade greater than on a two-dimensional graph, I'm going to shade above the line. So that's where we're at. We were initially on one-dimensional graphing, 1D graphing. Now we're at a stage where we're doing 2 dimensions because we're dealing with not only the x variable, the x axis, but also the y axis. So we're dealing with this in 2 dimensions. Similarly, in 3 dimensions, you would see something different, but we are definitely not going to be there in Algebra 1. So, going back to the notes, so the slope-intercept formula, I already just put it up there, is y equals m times x plus b. Okay? And the key to writing the slope-intercept formula is to make sure that y, I'm going to type this for you, y is by itself, right? And here in the slope formula, the m stands for slope, right? And that b represents the y-intercept. Y-intercept, or the place, it's the place where a line crosses the y-axis. That's my y-intercept. So the problem with the first one, so it says, so graph the line negative 2x plus 3y equals 6. The concern here is that y is not by itself. So we need to get it in slope-intercept form. So I'm going to do that. I'm going to rewrite this here and do some typing. So I have negative 2x x plus 3y equals 6. So the first thing I'm going to do is move the x term, right? Get y by itself, I move the x term. So I'm going to do the opposite of the x term, so I'm going to add 2x to both sides. of this equal sign equals plus 2x, right? And that part goes away, and I'm left with 3y coming down equaling 6 plus 2x. Then I divide 3 on each side, right? So I'm going to do that in pen. So remember, this goes away. So you divide 3 by each term. So 6 divided by 3, 2 over x divided by 3, and the 3's cancel. I get y equals 2 plus 2/3 times x. My slope here is 2/3, so I'm going to go up to right 3 for my pattern, and my y-intercept is at 2. So I'm going to start at this y-intercept here, start there, okay? So I'm going to do that in blue. So I start at 2, here's my y-intercept. There we go. And my pattern is up to right 3 and make a point. So up to right 3, make a point. If I'm going to go back the other way, I go down to left 3, make a point. Okay, and I want to create my line going through these points. So here's my line, and I'm done. Now, what if this had been an inequality? Well, given the same equation, right? I know the slope-intercept form of it already because I just did it. So I'm going to rewrite it, but with the inequality. Actually, I'm going to work through it just in case. Let's just work through it just in case. So I have negative 2x plus 3y is less than or equal to 6. Add 2x to both sides to move the x term. Okay, 2x on both sides. A little bit sloppy, but forgive me. This goes away. 3y's comes down. My inequality symbol comes down. 6 comes down. Plus 2x comes down. Okay. And what do I do after that? I divide by 3. I divide each term by 3, right? And I get y is less than or equal to 2 plus 2/3 times x. So here, my slope is once again 2/3. My y-intercept here is 2. So I'm going to go graph that y-intercept. It's at 2. And I'm going to go up to right 3, make a point. And to go backwards, I go down to left 3, make a point. So how do I graph this line? What do I need to do to graph this line? Well, first, I'm just going to tell you, all right? And we're going to go through it real quick. It's let's not graph the line yet. Let's just leave the points for right now. And we're going to come back and see what we need to do is to figure out 2 things. The type of line we're graphing and the direction of shading. Okay? Now, down below, we're going to talk about the type of line. So this refers to dotted or solid. That refers to the type of line. Type of line. Okay? And down here, the shading refers to the direction that we shade. Now, the type of line, if you have one of these, the following types of inequalities. If you have y is less than or equal to, or y is greater than or equal to, you're going to have a solid line. In addition, if you have x is less than or equal to, or x is greater than or equal to, you are going to use a solid line. On the other hand, let's say I have y is less than or y is greater than only, or or let's say I have x is less than some number, or x is greater than only. We're going to plot a dashed line. It's called a dashed line. It's dotted or dashed, whichever one you want. But so let's go back and look at our inequality. Our inequality is less than or equal to. So this is a solid line. So I'm going to go ahead and graph my solid line. And I want you to do the same thing. Graph a solid line here. And through those points. So that's what it looks like, right? Now, let's talk about the direction of shading. How do we shade? Typically, we've only been shading to the left if it's less than, or to the right if it's greater than. Well, so we have two things. If y is a variable, if there's a y variable, when there is a y variable, and we're going to type that. I'm going to type that for you. You need to write it down. When y is a variable, you will shade above the line or below the line. Okay? Now, when x is a variable by itself, you will shade to the left of the vertical line or to the right of the vertical line. Okay, so there's two cases here, and we need to be very careful and very cautious when x is a variable by itself. That's what you'll see. All right, so I'm just making that smaller. So we have two different cases. So what does it look like when y is a variable? Well, it looks like the equation above. So let's say I shade up when I have greater than. I shade up when I'm working with greater than. So y is greater than, or y is greater than or equal to. Okay? Now, so that means for when I'm working with my x variable, I shade right in a positive direction. Right, I shade right when x is greater than a number, some number. It has to be very specific. Some number. It's not y, not some other variable. Or x is greater than or equal to some number. I think that's very explicit in nature, right? Um, all right. So next we're going to deal with what does it look like for less than. Well, if we're dealing with, we have y is less than y is, or y is less than or equal to, then we're going to shade down. We're going to shade in the downward direction. We're going to shade below the line. And I like below the line or above the line for y. That's what you're dealing with. Now, if you're dealing with x, you're shading to the right of the line if it's greater than. However, if it's less than, then you're shading to the left. You're shading to the left. Shade to left of the line. Of line. Shade to left of line. And the situations where you do that, I just said it, but just to be clear, it's x is less than a number, less than some number, and it's very specific. It's not, you can't have a y variable in this, or x is less than or equal to. So the case we're dealing with above, we're dealing with, if we go back and look, y is less than or equal to, and so we're going to be shading in a downward direction. We're going to be shading below the line. So I usually shade with a highlighter because it's so much easier. So we shade on the line. We shade on the line. Since it's solid, you can shade on the line. And you shade below the line. All the area on this map below this line. And please don't get a highlighter and go and highlight the same spots 5 billion times and ruin your paper. I don't want you to do that. Just take your time and shade appropriately. Okay? So, sorry about my voice cracking. I still have a cold. But, so things that we do when we, what we use these inequalities for is we use it to identify solutions. Well, all of my solutions fall either on this line, because it's equal to, or somewhere in the shaded area. Okay, so that's a solution right there. 1, 1 is a solution. It meets the requirement of being less than this line. That point meets the requirement of being less than this line. So solutions, so points, let me type this for you because my handwriting's slapping on here when I can't control it with the pen. All right, so points that fall on the shaded side of inequality are solutions to the inequality. So we circle the points that are solutions to the graph, So I think in the next part, we're going to circle these points if they're solutions. So what I do here, what I would do and what I suggest you do is to plot the points. Plot the points. In order to solve this kind of problem, approach to answering this type of problem, you're going to plot the points. If the point is in the shaded area, or since this line is equal to, or on the line, it is a solution, and I can circle it. Okay? So I'm not going to do all of these problems. You're going to do half of them. I'm going to do half of them with you. You're going to do this half over here. Okay? So I'm going to go plot 0, 4. So 0, 4, and it's right here. This is in the shaded area. This is a solution, so I'm going to circle it. I'm going to plot -1, -5. It's down here. It is not a solution. It's not in the shaded area, so I can exit out. Let's see, 3, 3, -2. So right arrow over 3, and then down 2. There's a point. Okay, so it is in the shaded area, so I can circle it. Next point is 5, 5, 0. So that's right 5 and I don't go up or down, so it's just right here on the x-axis. And this is a solution, so I can shade it. So 0, 3. So 0 up 3, it's right on the line. And since this is a solid line, this is a solution. And then 1, 3, right arrow over 1, up 3, it is a solution. So these are solutions. So for the next part, you're going to work on this on your own, and I'm going to move on. Okay, so pause the video, work on this top part, and you can plot those points. If the point is in this shaded area or on the line, it is a solution. If you don't have this on your paper and you don't know how to do the problem on the review, I'm going to ask you to go back and watch the video. So make sure you write these things down, okay? Now, the next section, we're just going to be shading these lines. And I'm asking you to do a couple things here. I'm asking you to not only graph the line, I'm also asking you to get the slope, the y-intercept, shade, if it's, talk about the shade behavior, and talk about the line type behavior. So for this one, this is easy. We just need to create a fraction here, so we're going to divide by 1 for the slope so we can get our directional. And we're going down 1, and right 1. So we start at 1. Okay, down 1, right 1, and make our new points. Sorry about that big old dot, guys. Then down 1, right 1, make a new point right here. Down 1, right 1, make a new point. Down 1, right 1, make a new point. Down 1, right 1, make a new point. I'm going to erase these two here and do that over. So here's my points. Here's my points. Okay. Now I'm going to go back and draw the line here. So start down here on this very good point, and I draw it going up. There's my line. So the problem with this line is it's a solid line. This line is dashed. It's dashed. So I'm going to take that line off, right? And get me a dashed line. And I'm going to make it pink because I can. And start back over. It's dashed. So yours should be dashed as well. Dashed or dotted, however you want to say it. And now I'm going to shade it. And I shade above this line. So that means I shade going up. Shade up. I do not shade on the line because the dotted part is not a part of the solution. Do not shade the dotted part. You be very strategic and very careful there. Do not shade the dotted part. Now, for example 2, we're going to have to do some work here, guys. Right? So, which direction do we shade? It's greater than, so I shade above the line. And then the type of line is a dashed or dotted line. It's dashed or dotted. Now, for my slope, the number in front of x, since I always tell you already, I always tell you put a 1 in front and when there's no number in front of x. So my number in front of x is just 1. I need to create a fraction for my slope, so I divide by 1. My y-intercept is at 0 because there's no number added to that x. So I say I start at 0. I start at 0 here. Then I go up 1, right 1, make a point. 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 All right, and then I can get my ruler or whatever it is you need to make a line and create your line going down. And keep in mind, this is a dashed line. It's not solid, so you make sure you put your dashes in here. Make sure you put your dashes in. Let me see. Let's try that again. Okay. All right, so I start here, draw my line, pull them down. And now I'm shading above this line because it's greater than, y is greater than. So I'm going to choose a highlighter here and choose yellow and shade. And remember, don't shade on this dashed line. You shade above the line only because the dash part is not included. The line itself is not included in the solution. Looking at the next one. Let's see here. I have y is less than, y is less than. So when I'm doing this, the shade direction is down because it's less than. The type of line is a dashed line. My slope is 1, -1, divide by 1 to create that that run and start at 1. So here I am starting at 1, right? And I go, let's make that red. I go down 1, right 1, so down 1, right 1, make a point. 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 Create my line. And it's not supposed to be solid, so you got to be careful there. Make sure it's a dashed line. So I start here, it's dashed. And this is below, it's below. So I'm going to shade below this line. Try not to shade on top of the line because it's not a part of the solution. And look at that, beautiful. All right, so example 4 is very similar to example 2, so that's going to be part of your homework. I'm just going to highlight that it's a homework concern for you, and you do that. But I want to do example 5, example 6, and 2 more on the back, and the rest are for you to do actually during class. You should have time to do that during class. So first you shade, it's y greater than, so you shade above, and the line type is a solid line at this point. My slope is the same as the last one, so it's -1. Let me get a pen here. It's -1, and I want to create a fraction here, so I divide by 1, and my y-intercept is 1. So I start at 1, go down 1, right 1, make a point, down 1, right 1, make a point, down 1, right 1, make a point, down 1, right 1, make a point. Sorry. And this is a solid line at this point, so I'm feeling a lot more confident that I'm doing this correctly than I did above, where I kept making that mistake. And it's very easy to do that. Okay, but anyways, so I made my solid line. It's greater than, so I'm going to shade up, and make sure that's what I wrote here. That's what I wrote. I shade above the line. So I'm actually going to shade on this line because it's equal to. Now, for the next one, we're dealing with x, and a number. Remember what I said earlier, if you look back at the notes a little bit here, when you're dealing with x is less than number or x is greater than, you're dealing with shading right, you're dealing with shading left. So if it's less than, we're shading left. If it's right, it's greater than. So let's go check and see what we're working with here. We are working with x is less than the number, so we're going to be shading to the left. And it's a dashed line. The slope here is undefined. It's undefined, so I'm not even going to worry about that. It's undefined. It's who cares. The y-intercept doesn't exist. All right. So I'm going to go to the x-axis and find 3. And there's 3. There's 3. I'm going to get that off a highlighter there. I don't want that. Let me get a pen. And here's 3. Here's where x equals 3. And I can go all the way up and all the way down. X equals 3 at all of those points. I'm just going to create the dashed line to show the nature of this vertical line. So I'm going to get a straight line here, but I'm going to make sure it's dashed, and this vertical line goes up and down at 3, and I'm shading towards the left because it's less than. These are things you've already done before, right? Shading towards the left. Here's my line, and I don't want to shade on top of the line because it's dashed, but I do want to shade all of the solutions to the left of that line, right? Okay. So keeping that in mind, we're going to do 2 more examples. Example 1 and example 2. So for example 1, we have y is greater than 1. My slope is 0. This is a horizontal line, so I'm going to shade above because it's greater than. This is going to be a dashed line. So I'm going to go to the y-axis and fill these things in, but first my slope is 0 for horizontal lines. All right, so this line crosses the y-axis, and it's horizontal. This is a horizontal line. It's a horizontal line. So I'm going to go to the y-axis and go to where y is 1. Here we're at 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And these are all the points that are greater than 1. So this is a dashed line because it's not equal to 1. It's a dashed line because it's not equal to 1. But the solutions are all greater. They're greater than 1. Right? And there's my answer. There's my final answer. For example 2, the type of shading we're dealing with is a solid line. No. We're shading, its x is greater than, so we're shading to the right of 1. Okay, and the line type is a solid line. So I'm going to go pin this at 1. So 1, x is 1, x is equal to 1, x equals 1, x equals 1, all the way up and all the way down, right? And it's equal to, so it's a solid line. We're going to go back and do the slope and whatnot, so we're sure we're at the same page here. Now, the slope of all vertical lines is, I'm going to type it out, undefined. This line crosses the x-axis because its x is greater than or equal to 1. Okay. Now my shading is going to be towards the right of 1. Okay. And I do shade the line itself. All right. Example 3 and 4, you're going to do yourself. And the next 2 examples, these are in standard form. You're going to put them in slope-intercept form. If you've forgotten how, please refer back to the video when we did it right here. Okay, you get the y term by itself. I'll write the directions down below. You just need to follow them. So the directions are move the x term. And the second direction is divide by any coefficient or the number in front of y of y. Okay, so now we're going to compare and write the inequality equation that goes with each graph. I'm going to do these dashed ones first. Actually, I'll do this one first. So first thing we're going to do is to get our y-intercepts. So our y-intercept here is at -2, so -2. The slope, I'll pick two good points and get the slope. So here's one, here's a good point, and here's a good point. So I go up 1, so +1, +1, over +1, and then over 1, 2, divided by 2. That's my slope. So 1, positive 1/2. And I'm shading above, so this is greater than. The line, it's greater than. So up, the line type is solid, so it's equal to. So my symbol, my equation, it's equal to. So my equation is y is greater than or equal to positive 1/2 x minus 2. Down below, similarly, my y-intercept is at -2. My slope is 1/2. It's the same slope. Okay. I'm shading down, so it's less than. Y is less than. And the line type is equal to because it's solid. It's solid. So solid. So my equation, using that information, I know that y is less than or equal to 1/2 times x minus 2. Okay, so for the next one, the last two, same thing. Let's see, we're going to type this. My slope is 1/2. My y-intercept is -2. The shading here is above, so it's greater than. So y is greater than. And the line type is dashed, so it's only y is greater than. There's no equal to. So when I do my equation, I have y is greater than 1x over 2 minus 2. If you need me to write that out so you can see it appropriately, y is greater than 1/2. 1/2 looks a little bit different when I write it this way, but they mean the same thing. 1/2 x minus 2. Okay, last one, same slope, same y-intercept. So I'm going to type this. So I have the slope is 1/2, y-intercept is -2. Right? For my shading, I'm shading below the line. Wait, yeah, below the line. So y is less than. It's less than where this equation is, and the line type is dashed. So it's only y is less than. Okay, so when I write my equation, I have y is less than 1. I'm gonna go back and do that. Minus 2. There we go. So we're gonna divide by 1 divided by 2 times x minus 2. Okay, so that's all I have for you. Make sure you go back and do all those other things that that for your classwork. You do have homework tonight. Use the notes to help you complete the homework. All right, have a great day, guys.